Now these are the formulas we obtained earlier. Here again try to get the basic idea. If you have e to the power alpha x here, you just plug in alpha for d. That's all. In this case, if it's a function of d squared, if the function carries the function carrying the d operator is a function of d squared, you replace d squared by minus b squared. And here, if you have a product of two functions with one function is an exponential, then what should you do? You can pull out this function all the way from the operator and write it here. And if you do that, what happens is that you have to change d to d plus alpha. Okay. Now we'll go through these examples. Here, once I do these two, you can do the third one. It's a piece of cake. And when I do these two, you can do this one in the same way. These two are very similar. I'll do this one and I'll left this to you guys. Okay. So let's take the first one. It's so easy, right? Integration would be extremely difficult. Now d operator, once you are familiar with the d operators, it's just a piece of cake. You can simply get the answer easily. Here you know that fd can be a rational function, right? I just earlier when I tried to verify those formulas, I simply took some polynomial type d operator functions, but it's true for rational functions as well. So don't worry too much about that. You can simply, do this. Play the game in the same fashion. So this is a function of d. You have e to the power 2x. So what should you do? This is alpha. You replace d by alpha, d by 2. So this is 4 plus 2 plus 1 is 7. When you have this one, you have to replace d by minus 1. That's all. Easy. So you do the third one as well. Now take this one. This is fd. Now it is a function of d squared. Look, wherever you have d, it is in the form of a square. So what should you do? This is b. It is 3. So minus 3 squared. It is not minus 3 quantity squared. It is minus 3 squared. Should be a negative number. So this 9 and minus 9. Minus 9 plus 4 is minus 5. So you write the minus sign here. Now we'll go for this one. Now we are running into trouble. We straight away run into trouble. Look. This should be a function of d squared. That's what it says. Look, in these two cases, here minus sign is wrong. These functions should be functions of d squared. So here we straight away run into problems because look, this is not a function of d squared. You have some term which is not a d squared. Now I told you earlier, the operator theory allows you to play with it very easily, freely. Right? So what you do is, you forget about that d, right? You just consider this one. It's kind of weird, right? You have never done something like that in your life. You do it like this. You treat only that part. So this goes 2x. So you simplify this. This is minus 4. This is 2. So you have d minus 2. Now what? This is, look, this minus 4 plus 2, minus 2. Now what can you do? Now it's not a function of d squared. Now you are stuck. Right? So what should you do now? You make it a function of d squared. You make it a function of d squared. How do you do that? It's like all stuff. You multiply it by the conjugate. You can freely, play with this one. Now what? You can have it like d squared plus 4. Sorry, d squared minus 4. Now again what? this is a function of, this is not a function of d squared. Right? You have what? D squared only in this place. I told you earlier, the operator theory allows you to do it and play with it very freely. You just take care of this part. So substitute minus 2 squared for this one. Minus 2 squared. So what would you get? So what will you get now? This is minus 4, minus 4. You get minus 8. Minus 1 over 8. Then what do you have? You have d plus 2 cos 2x. Now the last line, minus. I'll put this 8 beneath this one. I'm going to write this answer. Now d plus 2 times cos 2x. Now you can break this into two parts. Now we are familiar with this one. We don't need two steps now, right? We can write it in one step. We can come up with the answer in one shot. So how can you do that? Derivative of cos 2x. This one. What is it? Minus 2 sin 2x. What else? 2 times cos 2x. I'll do it, now it's strange, right? We have done several strange things. We simply, some Indian, like South Indian male actors, like Kamal Hassan and Vijay, right? They violate all physical laws in the films, right? They challenge all physical laws. Similarly here, we challenge all form of mathematics, like, look at this. I just treated only this part. So you might ask, why don't you substitute the square root to that? We don't. Again, this one, once you do this, you again do the same thing. Right? Here, again you do the same thing. Now we'll do it, there are three ways of doing this problem. Right? I'll do it another way. Right? The second method now. This is almost similar to this one, but there's slight difference. Right? Okay, first we go through the same step. You substitute minus 2 squared here. Sorry. Should be like this. We keep d as it is. Now, this is minus 4, this is plus 2. So this is d minus 2. Right? After that, you multiply both upstairs and downstairs by d plus 2. Why would you do that? You want to make it, come up with the d squared in the downstairs. So far, both methods are the same. Now after this, okay, now you get this one. Using this example, I want to show that how freely you can work with this one. Now after this, here what did you do once you get this step? You substitute minus 2 squared for d squared. Now I'll do something completely different from this one, right? What I do is that I keep this guy as it is. I simplify this part because I know this part. D times cos 2, d cos 2x means its derivative. I'll write it like that, I'll write it here. D cos 2x is minus 2 sin 2x. Then 2 times cos 2x is this. Now what? Now apply this rule again. Apply this rule. How would you do that? Minus 2 times sine 2x, right? So I'll do it like this. Apply this rule one term at a time. You have this. You have minus 2. So what I can do is that I can write minus 2 here because it's linear, right? I'll put minus 2 here. You have sine 2x. Plus again, when you multiply these two, you get 2 to the upstairs. Now you apply this rule twice for sine 2x. I mean, here there are two ways of doing it. You plug in minus 2 squared here, or you deal with this part. Here you deal with this part first. But in the previous case, what did you do? You dealt with this part. That's the difference, right? Would you expect the same answer? I don't know. We'll see. We'll see. Right? Now, how would you deal with this one? It's solely a function of d squared. So you can substitute minus 2 squared for d. Oh, sorry. Upstairs you have 2 minus 2. Sorry. Right? Sine 2x plus, now you have 2 here. So, but what should you do? If you apply the formula, you substitute minus 2 squared here. Now what would you get? Minus 2 over, this is minus 8. Two over minus 8. Earlier we had 8 in the downstairs, right? Earlier you had 8 in the downstairs, so I'll keep 8 in the downstairs. The minus sign can be pulled out here. You have minus 2 sine 2x. Of course, you can simplify this. You can divide both upstairs and downstairs by 2, right? If I do it, and what happens is that you may not see it in the video. That's why I stopped at this point. Compare these two answers. Right? Compare these two answers. Look, it's funny, right? You completely took two different paths, but still you got the same answer. Look, here what did we do? Here you have cos x and we started with this one. We ignored this. In the second case, we give priority to what's in the upstairs. But in both cases, you got the same answer. So operator theory allows you to, play with this in a funny way. Now there's another method, of course. We'll do that as well. Right? Hold on, I have to erase this one for that. I'll do it somewhere here. For that you have only one method, but this guy, the previous problem, pertaining to the previous problem, there are three methods, right? This is the first. This is the second. Now I'm going to come up with the third method, right? Now look, you have cos 2x here. You can use Euler form to write cos 2x in exponential form, right? How do you do that? Let me put a star here, like this is the first method, this is the second method. Now I am going to come up with the third method. E to the power I theta is cos theta plus I sin theta. This is Euler form. So if you take the real parts of both sides, so cos theta can be written like this, the real part of e to the power I theta. So we'll take this problem. Sorry. This cos 2x. When you have cos theta, you can write it as e to the power I theta. Now look what happens. Here theta is 2x. So you can write this as real part of what? When it is 2x, this should be 2x. So it is e to the power 2ix. Now real part can be pulled out. So this equal to real part of this whole thing. Now it's easier because you write the straight away you can use that formula. What is alpha now? This is alpha. Alpha is 2i. Alpha is 2i. So substitute 2i there straight away. Because that's how you apply the first formula, right? E to the power 2ix will be there. I write I2x. You substitute 2i. Right. Now what is the square of 2i? It is minus 4. I just want to, because we have violated all form of algebraic rules in the previous methods. So I want to make sure that you understand that this method is correct. Now this will give you the same answer. So that means you can use whatever you want. There the answer is the important thing. Because the operator theory allows you to do all sort of things, and the operator theory is something beyond our scope. It is something you should learn after real analysis. Then you might say, you know real analysis. In the first year, no, that is just calculus, right? That is not real analysis. You don't know real analysis. Right? Therefore, we cannot understand operator theory, but operator theory allows you to do that. That would be enough for us, right? So this is minus 4 plus 2i plus 2. Remember that this is the third method. Now what should you do here? Minus 4 plus 2 is minus 2. Real part of. Now I'll write e to the power 2ix in terms of cosine sine. This is cos 2x plus, like this, right? Cos 2x plus I sin 2x. Downstairs you have 2i minus 2. Shall I pull out that minus sign? The real number, it's easier for us if the real number is positive, right? It's easier, you understand it better. So let me do it like this. 2, of course I can pull out 2. That would be even easier. I'll pull out minus 2. Now still we are nowhere closer to the final answer. When I pull out minus 2, you get 1 minus psi. Correct? I should put a bracket like this. Right? Minus 2 times 1 minus I. Upstairs you have cos 2x plus I sin 2x. Now, to find the real part, you have to make the downstairs real. To do that, you have to multiply it by the conjugate. 1 plus I. Upstairs, you have to multiply it by 1 plus I. Sorry. Now downstairs, what will you get? Downstairs, what will you get? You get minus 2 times, when you multiply these two, you get 1 plus 1, 2. So minus 2 times minus 2. Sorry, plus 2. Upstairs, I'll write it like this. Now I'm going to write the real part straight away. Downstairs, you have minus 4. What is the real part? There are 4 products, right? 1 times cos 6 is a real part, right? Cos 2x, I'm sorry. 1 times cos 2x. 1 times I sin 2x is not real. Now, product of these two, I cos 2x, no, it's not real. But when you multiply these two, I times I minus 1, so minus sin 2x, right? This is the same as the previous answer. Why? You have an 8 in the downstairs. I'll make it 8 and show that it's all answers are equal. I pull out this minus sign to the front. I'll make it 8. So what have I done? I have multiplied the downstairs by 2. So multiply the upstairs by 2 as well. When you multiply, I'll write this number first. So minus 2 sin, this term first. Minus 2 sin 2x plus 2 cos 2x. Look, this one is the same as this one, right? Okay, now we have the last problem. We can get into the last problem, right? The last problem, we try to deal with the third formula. So it's easy. What should you do? Let me recall the formula, because this is little complicated compared to, okay, you have some function, you have a product. What should you do? You pull out alpha all the way, e to the power alpha x all the way to the front. So in that process, this function is subjected to change. What's the change? D should be replaced by d plus alpha. Right, this is the formula, right? So let's do this. So 1 over this thing, d squared plus 6d plus 13 right? You pull out this all the way from the operator. In that process, what should you do? You have to replace d by d plus 3. I'm sorry, d minus 3. Alpha is minus 3. D minus 3 squared 6d minus 3 plus 13. You have only sin x in this side. It is in the operator, but e to the power minus 3x has been pulled out. Now, we can simplify this. You can expand it. D squared, then the term 2ab is 6d plus 9. Here you have plus 6d minus 18 plus 13. Now, e to the power minus 3x. Now you can simplify this. These two will go away. So 9 plus 13, 22 minus 18. Oh, this sin x, not sin 2x. Sin x. Right? So you get d squared plus 4. Now how do you do that? When you have something like this, you have to substitute, the value of b is 1, so you have to substitute minus b squared for d squared. So minus b squared is minus 1 squared, which is minus 1. This is 3. Right. Okay, this is how you play with these these formulas. Here I leave the 8th problem, the last problem for you. Last one is 8th one. Similarly, 6th and the 3rd parts are also left to you guys. Okay, thanks.